Good afternoon, everyone. And as I normally say, happy Thursday. Some days I feel like I repeat myself because I feel like I say the same thing as the intro of these webinars, so maybe I'll mix it up a little bit. How's your summer going? Hopefully well. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI, and I'm very excited today for this webinar and this demonstration on the geometric dimensioning and tolerancing extension available for Creo. This is a very, I don't want to use the word underrated. It's a phenomenal extension for Creo, but it is not used as widely as it should be used. I mean, what this product, what this software does is it really helps you model and machine apart to specifics, and also if you make a change anywhere, it's reflected everywhere. So I'm going to have Paul Dye, application engineer from PTC, lead the charge here today and do the overview on this solution, as well as a demo, so you can see this. But this can really help your engineering team become a lot more efficient and make your products, improve the quality of your products overall. So with that, Paul, I'm going to let you go into the details. I can see your screen and we're ready to go.
All right.
Take
and
it
you
away,
can hear
Paul.
me okay?
Hear you loud and clear, my friend.
Awesome. Well, thank you very much, Rob, for having me on. And thank you, everybody, for hopping on the call today. So again, my name is Paul Dye. I'm an application engineer here with PTC, and I cover everything within the Creo space. And today we're going to be going over a very important topic with model-based definition and geometric dimensioning and tolerancing. So, or GD&T or MBD, might use the abbreviated versions of those words just because it's a bit of a mouthful sometimes. But GD&T, as Rob mentioned, at a high level is crucial in any process that you're going to do, whether it be for designing, manufacturing. You need to get things built out to specifics, right? So GD&T typically is the key to a lot of that, right? So what I'm really going to be covering today is an extension that works primarily on what we see in the model-based definition space. So if you aren't aware of what model-based definition is, it's essentially doing all of your annotations and dimensions through 3D annotations on the model itself, rather than doing it on a two-dimensional drawing like you may have seen in the past. There are tons of companies that are starting to work into the model-based definition space. And I'm going to be going through today and showing an extension called the GD&T Advisor, which helps you to really do this type of dimensioning and tolerancing work through the use of model-based definition. I'll go through and explain everything. I'll go through and show what model-based definition looks like in the context of Creo, and a demonstration of the GD&T Advisor as well. So without further ado, we can go ahead and get into it. A lot of times I like to start into this by just going over some of the different challenges that we typically see out in the industry today around dimensioning and tolerancing, and looking at it from a side of these 2D prints. They're oftentimes very costly and also incomplete whenever it comes to transferring design information. It can be really hard work. It's difficult to get all the information in there and can really lead to a mess. And as you see on the screen here, these type of 2D drawings can be very, very visually challenging to read, let alone get all of that useful information into these. Reading drawings like this is almost a skill that seems to be dying off more and more nowadays. But as it still stands, it's really only one of the main ways that we have of transferring our designs from 3D modeling software into the real world. So that can be a big problem. And we thought that doing this type of work on the 3D model could be a solution to these type of problems. But those models out in the industry also have problems as well. It can still be quite a challenge to include all that information around dimensions, tolerances, and build that into the part. And that's because our drawing information contains lots of small details. You can't just have a model with all that information hanging off randomly. And around all that work that we do, there are standards that we have to be able to adapt to. And that's because these standards, whether it be ASME or ISO, are always evolving, and us as designers have to be able to keep up with that. And looking at it for your GD&T, this can be a very robust and effective way of communicating design intent from your parts and assemblies, but it can be very, very complex. There's lots of symbols, markers that you need to use and understand, And with those ever-changing standards, it can be a lot that you and your team have to keep up with. But for GD&T to be useful, it has to be complete, and most importantly, has to be correct. And it's because if your models aren't fully defined by those dimensions and tolerances, it kind of defeats the purpose if you have things that are wrong or in the wrong places. So in order to combat all those challenges, we have done a lot of work within Creo for giving you the tools to work with GD&T, to work with model-based definition, and make sure that we're validating everything that we're doing along the way. So it's kind of broken up into two main components I'm going to be covering today. The first of which being model-based definition and doing these type of 3D annotations, and then the second half being around the GD&T Advisor for validating the work that you're doing and making sure that you're building out everything correctly. So starting into it with model-based definition and detailing, we've enhanced a lot in this space around building out these 3D annotations. First, around your datum features, so all the symbols that you're working with that are required by the different standards, you need to use them. We have them all available for you. You can have favorites, or you can have most recently accessed symbols if you have ones that you oftentimes use. And now if you make any mistakes in laying out those dimensions, the system will tell you it understands how they work and will tell you exactly where something's wrong. We also made enhancements around things like datum targets, how we define those targets, defining callouts, also defining if the datum is within the target or not. That could be a personal preference or sometimes even standard for some companies. And a lot of improvements on creating GTOLs. So overall making it faster, easier, and whenever it gets complex, more accurate. So if you're getting an error or you're missing a component, let the system tell you, because the system has all these different standards that I mentioned all built into it. It knows whenever I need to either add something in or maybe remove something. And looking at annotations, we have a lot of enhancements in this space around, first and foremost, recognizing the surfaces that we reference in those annotations. So for example, if you happen to change a surface, the system will throw you a warning. So you can go through and edit any of those annotations. Also, the idea of combination states. This is where you can view different parts of your models or assemblies in different views, orientations, or view states. For example, here you can see on this model on screen, you had one dimension with just your standard type of model appearance. That could be difficult to understand what it's referencing. You could then instead set that outer surface to a more translucent display, and then it's very clear that you're referencing the inner diameter there. So just an example of how you could use these combination states for better showing your work, for better showing the design intent behind the dimensions that you're working with as well. All right, from here, we also have enhancements around fonts. We have new fonts for both text and symbols. It's like we saw earlier, you can customize them as well. Also, as soon as you click on one of these characters, it's going to put it into the right format, the right spot, does that automatically for us. And as those standards keep evolving, Creo is going to keep evolving right alongside them as well. So whether it be for ASME or ISO, as the standards get released, Creo is going to work to include them in any of your model-based definition and into any of the extensions that are tied to this. And then finally, for whenever it's time to share these models out, you need to have a way to view them. So we have lots of different ways for your front-end users to see all of these 3D annotations. First one is sharing out a step AP242 format, which is essentially a step file that includes all that information around the dimensions and tolerances. That can be saved out. You can do this as a JT file. Another big one is Creo View. This is a free to use application that people on the shop floor or any of your downstream suppliers or whatever it might be can use this tool for viewing up any of those annotations and the associated model with that. And those are all important because you need to be able to have a way to share those designs downstream with whoever necessary. So we give you many different ways of doing. Now, that's everything that we have and what I wanted to mention around model-based definition. Now, what's really going to help you out here is what we have in this extension called the GD&T Advisor. So this is an extension that's very powerful and very, very useful for people that are working in the model-based definition space. And this extension gives you expert guidance on the application of your GD&T as well as validation that has been done correctly. Now, at its core, it's a guide for users. So for example, say you go to apply a certain tolerance, it will give you suggestions based on the part or the feature that you selected. And it also won't allow you to apply a tolerance if, for example, it was invalid for a certain feature. It also informs you which features are fully constrained, which parts are unconstrained, or lets you know if you're somewhere in the middle as well. It also helps for educating the user. So for example, if you got a message in your advisor tree, you can ask for more help and it will give you context onto the advice that you're receiving and help you to better understand the changes that need to be made. As well, this extension is up to date with the latest ASME standards, same thing for ISO standards. So if you're working with either of those, we know that the GD&T information that we're building out is correct and it's being validated against those standards, whichever ones you want to set. And one of the biggest benefits that we have with this tool is also the seamless integration with Creo Parametric. You can just simply take the model that you're working with, go to the top, click the GD&T Advisor button, and get to work. And you're working in a very streamlined model tree where you have each feature along with all the associated tolerances. You're able to click edit any of those tolerances on the go, just like you would with your standard model tree that you might be using in the design space. And one option that we also have with the GD&T Advisor in a separate GD&T Advisor advanced option is the ability to use existing 3D annotations as well. So if you're working with that option, you actually don't need to get rid of any existing annotations that you built out. You can just simply take them and keep going. And that's something that I actually want to touch on here as well, is this, there was actually an advanced extension for the GD&T Advisor introduced a bit ago. So a little bit of background into this. Your standard GD&T Advisor extension, whenever you start into the process, doesn't recognize any 3D annotations that were created outside of the advisor. So normally users are prompted to delete all of those non-GD&T Advisor annotations. But what the advanced extension gives you is the ability to identify pre-existing annotations and then go through and reconstruct the required GD&T Advisor features as well. So it can take all those, identify them, recreate them in the GD&T Advisor. And not only that, it's able to validate that anything that was created previously is done correctly. So it'll go through, check all this against your standards. And if you do have any issues, it will, in the same way, give you the corrective actions to go through and fix any of those incorrect annotations. So whether it be datum feature symbols, dimensions, tolerances, works with any of those. So this is a function of our advanced license around the GD&T Advisor. That's one of the main functions that you're going to have there. The other big differentiator with the advanced option of the GD&T Advisor is the fact that it's able to work on assembly models as well. So with your standard GD&T Advisor, it's going to be able to do all that type of work on the part models. But if you need to work around assembly models, or you wanted to reuse any existing 3D annotations, that would be when you would want to work with the GD&T advanced option. All right, and with that, I can go through and show a demonstration of both model-based definition work as well as the GD&T Advisor in action. But before I do that, I could take a pause to see if we have any questions or anything I could explain more on.
No questions at this time, Paul. Oh, wait a second, hang on, there are a couple in there, I apologize. One question is, does GD&T Advisor work in assemblies and understand the assembly implications of GD&T, for example, tolerance stack up?
Yeah, so it does understand that. And this actually kind of plays into your other question, John, when you're asking what applications make use of Creo model-based definition data. You say, for example, feeding automated probing or machining. Yeah, so one of the big ones that you mentioned is doing tolerance stackups. So there is a tool within Creo called the Easy Tolerance Analysis tool, which is able to work with any of that GD&T information as well. So provided it's the correct characteristics, what it's able to do is take some of that GD&T or the tolerances that are associated with certain dimensions and build that into your stack ups, right? So if you wanted to do a type of tolerance stack up in one dimension, you'd be able to take any of that model-based definitions and build that into your tolerances as well. So, and build that into the stack ups. So that would be one example of working with the model-based definition in one of your other applications. For the example of probing, I'm assuming that would be some type of inspection type use case for a CMM. That would also work. It does take into account things like your 3D annotation. So working at it from a computer-aided verification side, it also would play into any of the inspections that you're doing there. For the machining, I'm not sure whether or not it would really play a part into the toolpaths that you're building out necessarily, but that one I would have to check on. I'm not sure necessarily whether or not it would change anything that you're doing from a machining standpoint.
Cool. So that seems to be it for the questions. Thank you, John.
Yeah, very good questions. Again, it does play a part into a few different areas for sure. A lot of the things that I've mentioned here probably won't make full sense if you haven't worked around them, but I could definitely go through here and show a few different examples, not only of working around 3D annotations, but also how that works into the GD&T Advisor as well. So we'll go ahead and get started here into our demonstration. We'll start off with a little bit of model-based definition work and laying out some tolerances. So we're going to be working on the scripper link from one of our designs, and we're starting off here in annotate mode. Essentially is used to keep these different sets of annotations grouped together in a clean, easy to use environment. And if we want to get started, we'll just start off with our geometric tolerance button. Say, for example, we wanted to apply a GTOL to our top surface here. We can go ahead and do that very easily. It's just as easy as clicking on the area that you want to apply it, drag it out into the right area, maybe set the geometric characteristic that you want to work with. In this case, it might be a flatness tolerance. And just like that, you're good to go. Quite often in that, you also need to add on a datum tag. And it's essentially the same process as defining the surface. Just click that, you're good to go. And once you've defined your reference, you can change how that tag looks. You can change where it's located, with or without an elbow, a few different options within that as well. But the whole process, as you can see, fast and easy, good to define that and keep moving on to other parts of the model. Go ahead and move into our second annotation set here. Maybe in this, we want to work with a dimension around the center bore. And starting with that, we can first and foremost drag out that dimension so we can see it a bit easier. Start by adding a tolerance to that value. Go ahead and take this 0.7 and give it a specific range of values that it can go up and down between. You're able to take those values set to whatever you need. And now I can go through and add in a geometric tolerance right on top of that dimension as well. In this case, the characteristic will be perpendicularity. And you can simply go through, put in your values, define which datum that you want to reference, and that's all going to update there for us. Now, very often in this process as well, you need symbols. You can see here that we can go through and access that full library of symbols. That's all fully customizable as well. You can add in a diameter symbol. Maybe, for example, you also need a maximum material. You can go ahead and add that in as well. And the GTOL block updates automatically for us. You can see there, if you added in one that wouldn't make sense for our scenario, throws you an error, says, hey, that's an invalid symbol you added in, just making sure that your values are correct in that sense. And as we did before, we need a datum tag. So for that one, we'll just pin it on the width line. We'll also add in the surfaces that we want to reference within that datum, and should be good to go there. All right, so now that we've finished up the definition for the center bore, we can move into defining these mounted holes down here. So we'll start by getting our diameter dimension, drag that away from the model. All right, and like we did with the other hole, we can lay out a range for that, even decide how many decimal places that should be displayed with that as well. And we can also make additions to any of these tolerances. So for example, since we have 4 of these holes, we can show that in our call out as well. And as you can see, the process is pain-free, completely easy to work with. You can add in a GTOL if you'd like to for this as well. In that case, it's going to be a position call out. And with that, we can go through, set any of the values that we might need to, check our references. In this one, we might have a secondary reference for datum B as well. So we can add that in. And in addition to all these capabilities, we can add in additional text to any of the sides of the call out as well for that additional information. So now whoever is seeing this on the front end knows that this is referencing all 4 sides, all 4 of those internal surfaces where those holes are in that case. And you're also going to click to define the surfaces as references. So again, the callouts aren't just numbers and letters. It's true intelligence. So it knows if anything was to change with those surfaces, it would be able to update for that as well. All right, I'm going to do a couple more here. Go ahead into our third annotation set. So like I mentioned, if you're working with that advanced extension, you're able to work with any of those annotations going forward as well. Work with ones that are already laid out. but that's what we want to do here is just lay a few more out. I need to set a perpendicularity in this case with reference to datum A. Go ahead and get rid of what we had before. A lot of times it will carry through what you had between different references because it makes it very easy for getting new ones built out, but we can just delete that if we don't want to repeat those callouts. Right, and now we can go through and see some of the different options that we have around building dimensions here in the model as well. So we can go through and get the maximum distance from one side to the next. It's very quick to go through and define a number of decimal places, exactly which surfaces that you want to reference with that as well. So for example, here, maybe we want to show the max dimension from one side to the next. Well, very easy to do that. And just like we did with the prefix, I can go through and set up a suffix there as well to show that this is going to be a reference. All right, once we get that in, we can go ahead and update our annotations and save the model off however you need to. And like I mentioned during the presentation, we have a number of different options that we can use here for saving off the model. You see, we have that new AP242 option that we can build out. Again, if you wanted to save it into a JT file, if you wanted to save it into a Creo view file, you can do that. And like you can see here, you can decide exactly what you want to reference or what you want to include in that publish as well. So annotations, datums, quotes, facets, lots of different options within there for what you want to publish out. Right, and now that it's saved off, you can send it out and it's ready to be used downstream for whatever purpose you might find necessary. So that's really what I wanted to show around the model-based definition side of things. Again, nothing that we worked with in there is necessarily using the GD&T Advisor yet. The GD&T Advisor is going to help us a lot in this process, like we're going to see. But I could take a brief pause and see if there's any questions on this from just the model-based definition side of things.
Yes, there are a couple more questions. One is, are corporate standard default tolerances supported for tolerance types?
Yeah, so the way that I'm understanding that is essentially what you're saying is you'd like to have, or for a company, they'd like to go through and set their own defaults around tolerances, which ones that they want to use, which ones they don't want to use, set it up from an ASME or ISO standpoint. So that's essentially something that you could do from the get-go for all of your users. So you could have essentially not like a template, but have these different defaults set up for your tolerances. That's definitely something that we see people do. They have standards that they want their employees and their designers to work around. So you could go through and have those defaults essentially laid out for any of your users. So from a default standpoint, that's definitely something you could go through and set up.
Okay. And the next question is, on the 4x call out, how does the system understand the associated geometry?
Yeah, so it's a good question as well. With any of the different 3D annotations that you're laying out, one of the big things that you're able to do with that as well is select on the specific surfaces that those annotations are tied to. So you're selecting on those surfaces, meaning that it understands what those surfaces are tied to, right? So anytime that you're building out any of those callouts, annotations, dimensions, tolerances, whatever it might be, you're able to go through and select on those specific surfaces. So it's tied to that geometry that the surfaces are bounding, right? So again, if any of those surfaces change or anything was deleted that those annotations were tied to, it understands that, it's able to update. And if a surface is now gone, it'll throw you a warning, say, hey, what you were referencing before is now gone or changed. What would you like to do, right? So
the change anywhere is reflected everywhere.
Yes, exactly. So that's definitely something that if you have something change in the model, it's probably something that you want to see or be aware of at the very least. So definitely something that is played into that process.
I think also, you mentioned this earlier too, is that I think due to the mathematic and function oriented evaluations with the GD&T Advisor, it cannot create an invalid annotation. It's extremely accurate.
Yeah, so actually that's one of the big differentiators here between your standard model-based definition process and what you would have with the GD&T Advisor actually. So what we were going through and doing there, it actually gives you free reign to go through and reference whatever you want or build out whatever you want in that case, right? So you could go through and put in any different characteristic, any type of reference or geometric reference in that case. But one thing that the GD&T Advisor does, which I'll go through here and show in a moment, is it essentially doesn't allow you to put through or put in any characteristics that wouldn't be valid for those cases, right? So it's really making sure that anything that you're laying out is going to be fully validated and it's not really going to let you make those type of mistakes.
Cool. Going back to John's question regarding the 4x callout, by the way, he was saying the definition of the 4x callout didn't reference the 4 holes, though. Yeah,
so what we did for the 4x was simply just a prefix, right? So that part specifically isn't referencing the 4 holes. So it's up to how you want to define it, right? So you could simply go through, and I can go through and show how that works on one of these models here as well. So you could either have it reference all 4 of the surfaces, or in that case, they may have just wanted to reference one surface and then from a prefix or from an additional text standpoint, use that in the callout. So you do have different options. If we wanted to say, for example, there, select all 4 different holes, then it could go through and reference that and build out a tolerance for that. I'll go through and show what that looks like here in the model as well. But yeah, in that case, it's simply just from a reference standpoint, only taking into account the one surface. But here I can also go through and show what it looks like if you want to reference more than just one. All right.
Sounds good.
So again, yeah, now I have a new model that I'm going to be working with here. And again, this is really going to be focusing in on the GD&T Advisor. So touching on a high level as well, again, this is really going to give you guidance on the application of your GD&T that we're going through and doing here, and as well as validation that everything that we've done has been done correctly. So if you want to get access into this, it's just an application that you have right up at the top, and the interface is going to be just the same as really anything that you would typically see within the context of Creo, right? So I'm going to go through and do a pretty similar process to what I did before. We'll go ahead and start on this top surface and pick what we want to do. And we'll see the main difference here. So whereas before we had, when we would want to go through and select a particular characteristic, we would have any of the options. What it's doing now here is it's graying out any of the different options that wouldn't be valid for the particular surface or definition that you want to lay out, right? And also what it would do here is highlight in green the ones that the system recommends in this case. So you can see here that it recommends profile of a surface. But if you have multiple different recommendations like you have here, it's going to put an asterisk next to the characteristic that's going to give you the most information or give you or really be the best for whatever particular scenario that you called out based on whatever standards that you're working on. So this is going to be the suggested constraint in this case. And we can just simply select that, right? And keep moving on, lay out your different values and get that built out very quickly. And I can still do the same type of things as I was doing before with any of those. If you wanted to build out an upper and lower range for that value, you could do that for any of these holes. In this case here, we're going to probably work with a perpendicularity characteristic, but we can see here whenever you would go through and select that, you see you actually have a few other options that are technically valid for this particular use case. But here it's probably best for users to just say, oh, hey, we can see here that perpendicularity is the recommended constraint for that feature. You could still work with any of the other ones, assuming they're valid, but really in a lot of the cases, you could just simply go through and have the GD&T Advisor allow you to see which one would be the best for that particular surface. All right. So again, very easy to work with. That's going to be our datum B. And once the annotations are all built out, they work just like standard annotations, right? You can go through and do everything that you would otherwise, but really GD&T Advisor makes it a lot faster. All right, we'll go ahead and take the center board down here on the bottom and go ahead and get our next feature built out. We'll first and foremost define a range for that value. And once we look back into the characteristic, we see that it recommends a positional tolerance for that as well. All right, you can still use any of those tolerances again, as long as they're valid, but in our case, we'll just simply work with the one that the system recommends. You can see here as well, we could also work with multiple different tolerances. In this case, I'll add in a parallelism for that feature in reference to datum A. And once we're done, we just simply click on the check to run our GTOL, and now we have a composite GTOL in this case. So not only fast and easy, but most importantly, accurate as well. And that's really what you want with this. You want to make sure that you're doing the right things. We'll go ahead and build out another one over here on the left-hand side. We'll start to define this other hole in the bottom. And for that one, we just need to use a positional tolerance. We'll give it a value, give it a reference, give it a specified range. And in that one, we don't need to build out a new datum there. We just accept it as is, and we can drag that box out so we're able to see it a little bit more clearly. All right, and now similar to before, I also want to show what it looks like to have one of these surfaces actually recognized in multiple different areas. So in this case, it's actually a pattern. We can obviously recognize that it's a pattern, but the system can also recognize that it's a pattern as well, right? We're able to apply whatever tolerance necessary, and we're able to take that and have it applied to multiple different instances of that hole. So a little bit different from what we had earlier here. Now we can actually have this positional tolerance applied to all 8 of those surfaces. You can see that it would now reference all 8 of those surfaces for that single one that we built out. Again, if anything would change there, anything were to be edited, we would also be able to see into that. So now it's referencing and was applied to all 8 of those. All right. So we can go ahead and keep working on a little bit around here as well. If we wanted to add in some additional text, we could also add that in too, so that it's being used in 2 different places. So that would be essentially what would be referenced over on the left-hand side. So you could build out another tolerance over on the left, but in this case here, we're just making reference over there in the prefix in this case. All right. Once we finish that call out, we can also check over in our advisor tree on the left and see if we're getting any errors. And actually, in this case, we do seem to be getting one. We're getting a 0 tolerance apparently isn't allowed. Well, sure enough, I must have forgot to put in a tolerance. We can just go right back in there, open back up the options that we have for that, and take that to find a certain range for that, given the values that it requires. And once we accept those changes, we can check over in the advisor tree, and now we have a valid dimension in that case. The last thing that I want to show here is a little bit of this show hide constraint state. This is actually a very powerful tool that we have here in the GD&T Advisor. So here, highlighted up in green, you can see exactly which surfaces are fully constrained. In gray, you can see which surfaces are currently unconstrained. And this really helps me to further understand exactly where I'm at with the model. And another thing that we have the option of doing throughout this is adding in a surface profile in the note as well. So that's something that we can go through and show very quickly what that would do. Up in our properties, what we can do is have this model controlled by an overall note. So in my case, I can say I want a general profile of 0.002 tolerance. And once we select that, we can see that up in the top left-hand corner, that gets added in as a note, but also our legend updates there. So now all the surfaces that were gray are all now blue, showing that it's constrained by a surface profile in the note. Right, and of course, once we're done within the GD&T Advisor, we still maintain all those callouts that we created, and we can get right back into modeling, move things around, make different features look exactly how we might like them to. You know, here, if we have an annotation that we built out incorrectly or had it upside down, we can very quickly change that orientation. So very fast, very easy to get those looking the way that you want as well. You just keep making changes, and it's on to the next one. And once you're finished there, you have a great geometrically tolerant part. You can save that part off and keep moving on with the design. All right, so that covers everything that I wanted to show from both the model-based definition side and from the GD&T Advisor side of things. I'll go ahead and really touch on just a couple last things here before I wrap up with the call. But before that, I was going to see, Rob, if we have any open questions currently.
No further questions at this time, but definitely an engaging audience.
Yes, definitely some really good questions and a lot of things that we typically see from people getting started into the process. There's definitely a lot of different considerations to take into account, but as you can see, very easy to work with and really a ton of value that we really get from working with this. Very quickly, I'll touch on some of the main things that we've seen people get tons of benefits out of. First and foremost, we see reduced scrap and failure that's typically caused by poor communication, right? If you were to underdefine something, And from people working over on the shop floor, that could lead to guesswork and oftentimes failed products. So something that we see a lot less of working in this process. We're going to be improving productivity. It's much easier to build these out from scratch, make edits, share them off, and just in general, working in an environment that's much more rich, has a lot more information available to the user. And from the GD&T Advisor standpoint, it's more educated designers, right? We always want to be better designers. We want to be more educated using that GD&T Advisor. We know exactly what each feature is doing. And if we don't, we now have a very quick and easy way to figure that out. And overall, just improving the quality of the designs or validating the tolerances at every step in the process. And if something were to be wrong, the system lets you know immediately. And that's done well before we would ever hit the save button, well before we would ever send that out to the shop floor. All right, and with that, that really covers everything that I wanted to touch on today. So I can pass it over to you, Rob, to wrap up.
Thanks, Paul. We do have another question that just came in. Creo's advances in model-based definition and GD&T Advisor are impressive. Kudos to the team. Oh, cool. Thank you, John. Thank you very much. Yeah, the thing is like, you know, this type of software, it's, I don't know, I think when you see a lot of like younger people coming out of college, a lot of them are using SolidWorks because it's easier to use, but you don't get a better model. You know, Creo gives you a great model. It's more sophisticated than SolidWorks. It's not really difficult to use, but there's that I think the misnomer that SolidWorks is easy. And it's not. It's Creo's easy too, but you know, you don't get as good of a model. But when you get into some of these extensions like the GD&T Advisor, they might be a little tricky to learn, but that's where we come in. I mean, we're proficient at teaching and training all the Creo extensions to new users or even experienced users as well. As a company, we give 2 hours of desk side coaching for every license of software that our customers have. So the minimum is 1 hour desk side coaching for every license of Creo that a customer has, but a minimum of 2 hours we'll give. So, you know, we want our customers to be able to excel, reduce, you know, increase their quality, reduce problems, reduce scrap and rework, and overall increase profits. So if you want any training regarding or any advice, or you want to have like a 20-minute call about some of the challenges that you have within your product development process, we're here to help you out. So you can respond to the email that I sent you. Any responses to the emails from this webinar that you've received, you can just reply. They come directly to me, or you can reach out to us at info@3hti.com. So next week, we are not going to have a webinar, but the following week, we are going to have a webinar on surfacing, and we're going to look at the another great extension, the interactive surface design webinar. So interactive surface design extension webinar. So that's a really, really cool extension. You know, makes surfacing a lot easier. So we've done this webinar in the past. We've always gotten great turnout for it. People are impressed with the solution. So that's why we keep running them again. So Paul, thank you very much for being on today. I want to thank our audience for being on, and we will see you in 2 weeks. Thanks, everyone. Take care.